Okay, number one. The questions for number one. Okay, somebody answer this. Look, you've got to have a few things like on the tip of your tongue as far as like memorized. So as soon as you see a problem, and the problem starts talking about whether there is a discontinuity or not, someone raise your hand and tell me what's the immediate thought that you should have. Like immediately, this should come to mind.
Should I factor?
No, I'll give you two for that. Factoring for sure. It comes up all the time. What else should come to your mind when I say the word discontinuity? Chance?
Hold, vertical asymptote, jump.
Perfect. 3 tickets for that. Hold, vertical asymptote, jump. Somebody else. You look at this one, immediately there should be a subsequent thought.
Is it like a piecewise function or?
Nice. Piecewise or rational. So what do you think? No, perfect. Actually, 2 points. 2 points every time I call on you. So you're asking yourself, is this function here in number one, is this a piecewise or is it a rational function? Somebody tell me why she's thinking that. Go.
Because piecewise will have a jump and everything else.
Nice. Only piecewise has jumps, and only rational has holes and vertical asymptotes. Good question. So for this one, we're not looking for jumps, but we do need to worry about holes, vertical asymptotes. Do exactly what Deborah said. First thing we do is factor it quickly. So let's see. So we got f of x going to equal, I'll pay someone to factor it so I don't have to sit here and think. So Jeff.
X plus 3, x plus 2.
2 points, somebody else. Let's go, Ellie.
X plus 3, x minus 2.
Pause here. Without a question. Once it's factored, someone should be able to raise their hand and make a comment about what we've discovered. Somebody else. Let's go. Maddie?
The whole got negative 3.
Nice. So Maddie first notices that there is a factor in the numerator, which matches a factor in the denominator. That causes a hole. Someone else? Let's go back here to Chad.
The vertical asymptote's at 2.
Nice. Chad notices that there's a remaining factor in the denominator causing the vertical asymptote. Anyone have a question? Okay, let's go to the next one. Oh, the limits, yes. The limit was kind of a review from the previous homework, so I'll answer this if you need, otherwise we'll kind of just leave this one alone. Does anyone show me your hand if you need me to talk about the limit? Okay, so the limit question says, take the function f, so here's the function f, and find the limit of the function for an x value that is very close to -3. Very close to -3. I'm going to use this version of the function because in this version I can identify that this portion of the function is going to divide to make 1 as long as x isn't -3. So all that's left to do, cross this off, is find, let's see, x, y, I plug in a little less than 3, so that's going to be -3 minus plus 2, all over -3 minus 2. That's pretty darn close. -1 over -5. Negative divided by negative is a positive, so the limit should be 1/5. Follow-up questions? Anyone comfortable with that? Awesome. So, okay. Let's go to the next one, 2. I never want to go faster than you can take notes. So if I get ready to erase and you're still taking notes, just say, wait a second. We'll just take a break. You guys are writing. joke. My mind's gone blank. I can't come up with any impressions too much. Those jokes.
You know a good joke there?
Oh, here's one while you're waiting. So a teacher, did I tell you the limit joke already?
You did now.
Dang.
You can do it.
Ah. A student told me a joke yesterday. It's one of those another ha-ha jokes. She said, I got a math joke for you, Mr. Smith. She said, what do you, if a student tells you that she's cold, or he's cold, what should you do? I'm like, I don't know. She's like, just tell him to stand in a corner because in a corner it's always 90 degrees. So. I should have pushed pause before he told that joke. So. Okay. Yeah.
How do cows count?
How do cows count?
They use a calculator.
They use a calculator. Should have pushed pause. All right, here we go. Number 2.
She's in London right now. Can we just really look over the student?
It's the old rule. Like, hopefully, you're now on the internet forever. So.
Yeah.
What? No.
All right, anyone have a question today? Hey, don't talk. Anyone have a question here? Same idea. Once the function is factored, pretty easy to find the holes and or vertical asymptotes. I always look for holes first. I found that to be less error prone. I've seen students who, if they identify the vertical asymptotes first, they tend to make mistakes. So I know that there is a factor in the numerator which matches a factor in the denominator. That causes a hole. The remaining factor in the denominator causes the vertical asymptote. The extra factor in the numerator causes what's known as a 0, but we're not being asked about that, so we'll see about it. Question? Good? You have a follow-up question about this one about Amy? Okay, let's go to the next one. So number 9. That's good. Number 9. All right, for number 9, we're going to do something different just to get some tickets flowing.
Yes.
So here's how this game is played. You raise your hand, I say your name, you add something to the process, you give yourself 5 tickets. But you only do it once for this round, just this round. Just do it once, don't take it twice. Only one set of 5 tickets. And you only say as much as I kind of let you say, so don't be surprised if I kind of cut you off and then pass the baton to someone else. Everybody got the idea? Okay, cool. So let's go f of x here. Jeff, go ahead.
You got a factor out.
Nice. 5 for Jeff. Let's go to Oakley.
You can factor out the x and the
Oh, nice. X. I thought you said top. My bad.
top.
5. Who's next? Oh, Deborah.
Bottom.
So she said the bottom. That's good. Who's next? Lexi.
So you'll get x and then difference.
Oh, nicely done. Who's next? Let's go over to Chad.
Can I keep going on the bottom?
Sure.
You'll get x squared
Pause. Nice.
Okay.
Tavia.
3x.
Oh, you missed something. Plus. There you go. Somebody else. Let's go to the back. Kel.
On the top you'll get 1 plus x.
1 plus x here. Someone else. Let's go to Brady.
On the bottom is plus 2.
Let's go to Harris.
Parentheses and on the top.
Oh, nice. Let's go to Eric.
Bottom.
Nice. Keep going here. Keep going, keep going. So the top is completely factored. On the bottom, we can get a few more 5-ticket people to join in the, Sarah.
X divided
Oh, thank you. I'll do that in a second. We'll just pause and everything.
10.
We'll leave that alone for a second, but no, it's perfect. 5 tickets. Let's go, Brady.
In one parentheses, you have x plus 2.
Go to someone else. Let's jump over here to Amanda. X plus 1.
So smart.
You stop there for a second. We'll come back. Hold on. Is
Yes,
everyone
sure.
comfortable? Any questions so far?
Sure you can.
Someone else who'd like 5 tickets, jump in still. Heidi?
the x plus 1 and 1 plus x cannot become 1 equal
So what does that cause?
a whole.
Whole. Now, Heidi is not one to normally use profanity, so I was a little shocked. Don't say cancel. Someone else, please. Let's go, Jackson.
The x is on the left, divided 1.
Nice. So they cause another whole where, Jackson?
At 0.
Perfect. Any questions first? Any questions? Let's go, Ellie. Perfect. You have a question? Any follow-up questions at all on this one? Okay, next one.
This round two.
Hold on, still in the 5-ticket round. This is the first one. We gotta stay on the first one here for a second. So 9 is down, go to 10. Someone who has not picked up 5 tickets left yet, if you'd like to raise your hand, we'll call on you. Let's go ask.
You can factor out 2x on the bottom.
Put 2x here. Someone else? Kelly.
X minus 4.
X minus 4. Someone else? Len?
And then on the top one, it just be 2x.
Perfect. Next. Everybody. There you go, Kelsey. So the 2 factors here, divide to make 1. What does that cause, Kelsey? At what x coordinate? Perfect. Listen. Perfect as well. Anyone have a question? Follow-up question? Right? You should be noticing mostly practice in factoring. Most of it's just practicing doing that. You asked for 11. Oh. Or we keep going, but you're okay. What's that? You're okay. Wait a second, let me actually put the notes. 11. That's why. Let me just. Here we go on 11. So anyone who's still didn't get 5 tickets would like to join in? To the left? Top.
Reset.
Reset, yeah.
On the top, that would be 2x.
Nice. What else?
This can be
Sort of.
on the bottom, you can back up
Nice. What else?
I have a question.
Please, Chad.
So like, when you factor something out, it doesn't have to be the same on top and bottom?
No.
Okay.
Ideally, hey, listen, please. Ideally, we are looking for a factor in the numerator which will match a factor in the denominator so we can divide them.
Okay.
But in this case, not quite the same, but good enough because the x is still divides. Sarah.
The x minus 5 on the top.
Nice. What else?
On the
Kimmy.
bottom, x squared minus x minus
Thank you. Go again. Please. Joe, Amanda. There we go, Jen.
X plus 1.
Move left. Pretty good. Anyone else? Amanda? So the matching factors cause a pole. Anyone else? Let's go to type.
Vertical asymptote and negative 4.
Move left. Oh, here we go.
What x equals
Nice. A pole at x equal 5 and a pole at x equals 6. Okay, anyone have a follow-up question? Okay, the question actually asks about the limit. So, making some space here. As x approaches 5, 5 and 0 are both actually. 5. Plug in a little bit less than 5. I look over here at the formula for the function. And I note that when x is equal to close to 5, this still divides to make 1. This still divides to make 1. So I get a much simpler problem to deal with. I just have to look at this. 2 over, let's see, plug in 5 minus. So that's going to be pretty close to 2 over 9. The same would happen if I plugged in a little bit more than 5. Find your mistake, actually.
Yeah.
Questions? Anything? All right, moving on here. 15. Okay, the 5-ticket per person game was working pretty well. We'll reset round 2. Somebody make a comment about 13. Go ahead. Jackson.
You look for jumps
And why not poles or vertical axis?
because there's no rational numbers.
Perfect. This function has no rational fraction. Sorry, I said that all wrong. Rational function. Rational function. So the only thing we're concerned about is a jump. Someone else talk to me about the jump. Nice. Looking at 13 here. Plug in 3. That's 5 for Jackson, 5 for Deborah. So this comes out to be exactly 7. Someone else comment. Sort of.
Then you do the bottom one, so 3 times 2 plus 1.
Technically a little more than 3, but
Yeah.
no, you're fine. That's pretty darn close to 7. No jump. No jump. Stole it from you. Oh, hold on. Question?
So why don't you or like a little bit below?
Oh, got it. I think so. Hold on a second, Ellie. So here's the thing to memorize. Everyone, please. If you are, okay, remember, a function is just a list of xy pairs, and a jump occurs when you are, look down the list of xy pairs. A jump occurs if for some x coordinate, like xy coordinate, the very next xy coordinate or the one before it the very next one, the very next one, 2 to 2 plus. If this y coordinate is not either like a little less than 8, or exactly 8, or a little more than 8, that's going to cause a jump.
Okay, so it has to be on X.
To make sure there's not, yes, the x coordinate, the idea of a jump is as you are going from one x coordinate, like say 2, to another x coordinate that's infinitesimally close, the corresponding y coordinates must remain infinitesimally close. Otherwise you have a jump. So the reason we don't worry about x equals 0 over here is if we were to plug in, we can't plug in exactly 0, but you can plug in a little bit more. So we could do this. We could say, plug in a little more than 0. That's going to be a little more than 0 squared minus 2. So that's going to be really close to negative 2. Well, the very next x coordinate would just be a teeny bit more than that. Like, I don't know, 0 plus plus. But that's going to result in a y coordinate that is still extremely close to negative 2. So no jump. And the reason I don't have to worry about it is if I'm plugging x coordinates into the same formula, there will never be a jump between two x coordinates in the same formula. The jump only occurs when you stop using one formula and start using another. If that makes sense. 2 tickets.
Do you need to write out numbers at asymptote or no holes, or is it cool just to do no jump?
Oh, great question. Technically, I should write no hole, no vertical asymptote. If I'm taking the AP test, I want to make sure the grader clearly understands that I understand it. So, good question. What else? Sweet. Last one, 15. Everyone in the room, look at 15. Everyone look at the term I just circled. Like everyone look at it, please. You should memorize something. Add it to your list of things to memorize. Now, I've actually tried very, very hard to come up with like the smallest list possible of key facts to have memorized. So if I say memorize it, it's on that key list. When I see something like x cubed plus 9, I immediately recognize that it cannot be factored. The simple thing to remember is this. If you see a difference, like x squared minus 9, that can be factored. But a sum, two things added, for our class, that kind of factoring is too complex. They're not going to ask you to factor anything like that. Unless it's simple, meaning you can just take out an x or take out something like that. But it will never become the binomial type factoring. Like this x cubed plus 9 is not going to end up being factored like this. Just memorize it, get used to seeing it. Any question? So because it doesn't factor, this part of the piecewise function, all I worry about is a vertical asymptote. Question? Todd, please.
So does the bottom, like, since it's a square, does that mean that there's no way?
Oh, thank you. 2 for Todd. Todd, notice this. The denominator has 2 factors. The factors are x plus 3 and another x plus 3. We don't refer to that as 2 separate asymptotes, vertical asymptotes, because they're both occurring at x equal negative 3. We simply refer to it as a single vertical asymptote at x equal negative 3. Is that what you meant? Question? What else? All right. Okay. New stuff today. The homework, I'll tell you what it is right now, then we'll talk about it, like how you're going to accomplish it. The homework is problems 16 through, oh my bad, sorry, next page, sorry, it's 18, thank you. The homework is 18 through 25. Homework is 18 through 25. Homework is 18 through 25. Okay, no one talk, everyone look up now. No one talk, make sure your phone's put away now. The new stuff, you're okay. Okay, I gotta see that you're focused on this one. Because what happened last period was a few people kind of drifted into the idea of like, well, I'll just watch the steps and that'll be good enough. They lost track of the big picture. Pretty soon they're very confused about what they're supposed to be doing. In this class, the big picture is always the most important part. Make sense of the big idea, the little steps become easy. So stay focused on the big idea. The little steps are not hard. The big idea. For the homework, I'm giving you 8 different functions. And I'm asking you to figure out a way to ensure that all 8 functions are continuous. That's the goal for all 8 problems. Any question about the objective? That's the big idea. Okay, now when I say make it continuous, we'll keep paying some tickets here. Somebody raise your hand and tell me what's your first thought when I say continuous, Heidi?
It doesn't have like jumps in it.
No jumps. What else? Somebody else. Go. No holes or vertical asymptotes as well. Thank you, Sarah. I got to make sure that these functions are continuous. So they can't have any holes, they can't have any jumps, they can't have any vertical asymptotes. Question. Awesome. 19 is where we're going to start talking as an example. Okay, again, we're thinking big picture here. So I'm not worried about steps at all. But as I look at 19, I immediately recognize something that fits in this big picture. Looking for someone to recognize what I am recognizing. Deborah's in for 2 more. Who else? Let's go, Lexi. Perfect. So Lexi says no holes, no vertical asymptotes. I don't need to worry about them. Question for Lexi. I do have to worry about jumps, but I observe something else about the jumps. Who can see what I'm seeing about jumps? Like all this is just thinking. I'm not doing any steps. I'm just thinking through it. Jackson,
It could be a max of 2 jumps.
nice. So I could have at least kind of a maximum of 2. So I guess I should say possible here. Let's back this up. So possible jumps. 2 for Jackson. Somebody tell me what else can I say about jumps? There's another key fact I can just look at the problem and recognize related to the fact that there are 2 possible jumps. Someone will see it. Ellie? Nice. So possible jumps at x equal 2 and or x equal 4. Anyone having any questions about where we're headed? Now, like really note how we are not solving the problem step by step. We're just talking about it. And if you can learn to do that in this class, you are on the road to success. Just learn to talk about the problem. I've helped a lot of students. The students who can come to me and talk about the problem, they always end up being successful, always. The ones who get too fixated on steps struggle mightily, okay? Very good. I joke that I'm like the math psychiatrist. You come in the room, you sit down, you talk about your problems a little bit, and you leave feeling much better. So that was kind of okay. My jokes are the worst because I have to prompt you to laugh, and I appreciate the support. Okay. So we're worried about jumps possibly at x equal 2 and x equal 4. We've got to make sure that we do not have a jump at those 2 x coordinates. Here's how you think about jumps. It was what I was talking to Ellie about. She understood it very well. So cross this off so we can use this space. A function is a list of xy pairs. Okay. We start plugging in x coordinates. Theoretically, you could plug in an x coordinate all the way at -infinity on this function. We plug in many more x coordinates. Eventually, you get to say x equal maybe -5. You plug in some more, you get to like x equals 0. Someone please tell me, how would we find the y coordinates for all of these different x coordinates? How would we find the y coordinates? Let's go over.
You just plug in x into which one it says to go.
Nice, perfect. 2 points. So to look at the function here, f of x, and you identify, is it this formula, this one, or this one, for which I'll find all of these y coordinates. Somebody tell me which one is it. Let's go Braden. The top one. So 2 for Braden. So these plug in, find all of these different y coordinates using the top formula. Okay, as long as we are using a single formula, there is not going to be a jump. Is everyone clear on that? The only place a jump can possibly occur is when we change from one formula to the next. So we've already identified that the place we're curious about is 2. So hey, I'm not solving the problem, I'm just kind of thinking through it. So I'm going to find out what's happening at 2. So I plug it in. Let's see, that's going to be a 2 plus 1 squared. Okay, so here's a question. I'll pay, I'm not sure how many I'll pay, depends on how good your answer is. What does this symbol 9a represent? Keeping track of what the symbols represent, extremely important in this class. You don't just say, oh, well, here's a number, there's a number, I put them together, I get an answer. You've got to keep track of what they mean. So I want to talk about what does 9a represent? Looking for a hand. Heidi thinks maybe 2 for Heidi. Anybody else? Go ahead. No, give it a shot. Perfect.
Does it just mean that that's what y equals at when x is 2?
Perfect. 5 tickets for bravery. When x is 2, y is some value called 9a. So stay with me for a second, Heidi. So if a were equal to 1 at x equal 2, what would the y coordinate be?
If y were equal
Sorry, if a were equal to 1
okay.
at x equal 2, what would the y coordinate be?
4a.
Oh, I said my question came out all wrong. I'm sorry.
Okay.
If x is equal to 2
Okay.
and a is equal to 1, it would have a coordinate at 2, 9.
Yeah.
Make sense? If a is equal to 2, what's the y coordinate? 18. If a is equal to 3, the y coordinate is 27. Okay, good. Anyone have a question? Awesome. I'm supposed to make sure that this function does not have a jump. So it goes back to what I talked to Ellie about. I've got to go to the very next infinitesimally close x coordinate. Someone tell me, what is the very next infinitesimally close? Todd? Perfect. Someone else tell me, how do I find the y coordinate that goes with that x? Braden's in for 2, Jeff's in for 2. Go, Jacob.
Middle equation.
Perfect. 2 for Jacob. That's going to be really close to a value of 18. We have a question.
Say plus 14.
That would be better. 2 for Oprah. Thank you. Moving else. All right. We're supposed to make sure there are no jumps, and we ensure that by choosing an appropriate value for the letter A. Raise your hand, the whole room. Everyone who can see what A should be, just raise your hand, please. We do not want to have a jump. What value should we pick for A? Everyone who knows, I'll pick everyone who raises their hand. What should we pick for A? We're trying to make sure that there is not a jump. Remembering what Ellie brought this up. X is changing by an infinitesimal amount. The y coordinate can only change by an infinitesimal amount. So what should this be? So don't put your hand down. I want to see everyone who got it. Go to Kimmy. What's the answer, Kimmy?
2.
How many would have said 2? 2 points, 3 for Kimmy. Do you have any question about that? Please. We have to choose it appropriately.
Yeah,
that's,
but you didn't choose it.
that's the whole idea, Ellie. This A could represent any value. We've got to choose the specific value that will ensure that this function right here no longer has a jump. That's the whole idea. Perfect. 2 more tickets. Anyone else? Awesome. Okay, I'll let you finish this one and the other 3 as homework. I'm going to jump ahead for a second. So you still have to find B. So jump ahead to the next page. Oops, quick.
Would we not need to do them self or B?
You do. So I'm going to leave that as
Oh,
homework.
wait, oh.
No, perfect. You still need to find B in number 19. I'm just leaving that as homework. Perfect. Let everyone catch the notes for a second.
The homework is just, so if it's continuous, then you just have to find A and B.
the idea of the homework is you have been given 8 different functions. Each of those functions has a value which you don't know what it is. This one has 2 of them, A and B. The instructions say that. So you can you're supposed to figure out what A and B have to be to ensure the function is continuous. And really, Ellie, it's much more about understanding an idea than it is about any sort of steps. As you saw, the math is very simple. That's not the hard part.
So, we're trying, okay, we're trying to get them to jump, so.
We don't want to jump.
Yeah, we don't want that at all, so, we try both, we do both of them, but we want them to do the same.
Exactly.
Answer, so we want to find what A goes to, that would be 2, so.
No, you're seeing it, Cal, that's perfect. If you think of a graph, here's what you're accomplishing. At an x coordinate of 2, actually it's a little easier to think of it this way. At an x coordinate that's a little bit more than 2, 2 plus, we know the y coordinate is pretty darn close to 18. So there's a point here at 2 comma, 2 plus, comma, close to 18. We've got to make sure that the dot that's just on this side of it is right next to it. So it's got to be right here. Its x coordinate is no, it's got to be 2. Its y coordinate needs to be 18 as well. Otherwise, you have a jump. Does that help? Someone else? All right, please turn to problem number, it's on the next page.
Yeah.
24. Turn to problem 24. I'm going to cross out 25 because we'll probably end up using this space on the board, so don't pay attention to 25. Okay, new problem, so everyone look up. This one is totally different than the previous. So everyone look at me, you gotta have your faces up again. This one's different, so I don't want you, I love that you kind of moved on to the homework. That's perfect, doesn't bother me a bit. Just don't want you to miss this, because it is different. The same thing, we've got to learn to just talk through it. Talk through it, okay? Somebody remind the class, raise your hand, what's the goal? Let's go, Sarah.
We want to find the A that will
Perfect. We want to find the value of A, which will ensure, that's perfectly said, Sarah, 3 tickets. We want to find the value of A, which will ensure that F is one continuous graph. One way to think of a continuous graph is, again, a list. You want a list of XY pairs. Make me a list here. And I want to make sure that as I'm making this list, every time I choose an X coordinate, let's say -5, the Y coordinate that I find, first of all, there has to be a Y coordinate. If I plug in an X coordinate, there is no Y coordinate, the function is right away not continuous. Everyone hear that? So if I plug in an X and I get no Y coordinates undefined, the function is already not continuous. So I can't have that happen. But I've also got to make sure what we took care of in the last problem, if I plug in a value that's just a little bit more, the value that I find has got to be very close. So these got to be like next to each other, infinitesimally close. Tough word, I hope it's spelled right. Infinitesimally close. Is there anything they want to talk about as far as understanding the idea? You've got to make sense of the idea first, otherwise the problem just makes no sense. Okay, so far? All right, so this is the goal. I look at the function, and this one is very, it's subtly different than the one we just worked on. Who can notice a difference? Let's point out something that's different. So 2 for Braden, Sarah, who else is there? Heidi's in for 2, Oakley, Lexi, Landon, go ahead.
It's possible to have an AD for a class code
Nice. And why, Landon? How do you know?
because it's like it's dividing.
Good enough, good enough. The technical term is rational function. I don't even
Yeah.
care. I really don't care about that. You're remembering the idea, and that's what's important. He looks at the formula in line and says, hey, there's a division occurring in this formula that can cause a vertical asymptote and a hole. So either one, either one. Perfect. In fact, as soon as I see that, I'm like, I start to get this impulse to do something. You can read my mind. Go.
Add a factor.
Factor it. If we factor it, we're going to see better what's happening. So let's do that. Come over here. So let's draw a line like this. Somebody help with factoring. So Sarah.
Yes, walk me through that thing.
10. These are 2 points each. So somebody else. Let's go, Maddie.
X squared.
Keep going, Maddie.
X squared minus 2x minus
Nice. So what else? Let's go back.
8. You can factor it again to x minus 4 or x equals
Actually, I was kind of thinking something else. So what you're doing is perfect. Max, I just was thinking something else. So say it one more time, Leslie. Sorry.
2. X minus 4, x minus 0.
Thank you. Just in the way. Does anyone have a question about factoring? Questions about the factoring? Focus is perfect. Everyone good? Okay, as soon as we factor, we learn something. Okay, I'm just going to keep saying this all year long. This is not a step-by-step process. Calculus just isn't. It's more like, hey, we understand the problem, what can we learn about it? People ask me all the time, why should I take calculus? This is why. You're not going to use this in a job, but the way you learn to think, you will use. Like, that's how people think in real careers. It's not a sequential thing. It's more like, I mean, even doctors, when you come in and you talk to the doctor, he looks at the clues, right? How do you feel? Let's take some blood work. He looks at all the different clues. He somehow has to come up out of his head how it all fits together. It's a really good analogy. Chance, please.
So I have a question.
Please.
So the x plus 2 and the x plus 2 on the top and the bottom make it so there's a vertical asymptote. But if you look the other place, will that x, where the x equals minus 2, make that vertical asymptote obsolete because you can plug that a in?
Oh, you're right on track. You just used the wrong word. No worries. Perfect, Chance. 3 tickets. What he said was x plus 2 is a factor of the numerator. It's also a factor of the denominator. And so what it really causes is a hole.
Oh yeah.
Yeah, no worries. So we know that there's a hole at x equal -2. And what Chance said was he understands enough about holes to jump to the next conclusion. He jumps over here and says, okay, at x equal -2, if I plug -2 into the formula, I'm going to get undefined. That's what a hole is. But if you look at f of x, they've solved that problem for you. Because it says, use this formula for every x value except 1. In other words, all of these different x values, the y values are found using the formula until we get to exactly -2. And then we no longer use this formula. Instead, we find the y coordinate to be a. So for f of x, this is a. Now that was a mouthful, so now's a good time to talk a little bit. Sarah.
So then, are we just looking for what a equals to the vertical asymptote? Because there's so many. Oh,
Talking.
so there's no vertical asymptote because the bottom, like, to make it 0 and -2. I just don't get it.
Let me say it back to you. So you're actually really close. Okay, if we look at this formula, we know that if x is equal to -2, the denominator of the formula will become 0, but so will the numerator. So that's not a vertical asymptote, that's a hole.
So then,
So there's no vertical asymptote because there's no remaining factor in the denominator which can cause the denominator alone to become 0. Okay with that?
yeah.
So the good news is this formula, here again, this formula only has a hole. The hole is located at x equal -2. So what I now understand is if I'm plugging in x and y coordinates, like so, there's not going to be any problem with any of these because they're all being plugged into the same formula. You're not going to find any holes because we already identified the hole. You're not going to find any vertical asymptotes because it doesn't have any. And it can't have any jumps because you're using a single formula. So for all of these XY pairs, there's not going to be any problem. Does that help a little bit? Good. Anybody else? Please.
So is that why you find the whole first for the so?
Well, I actually wasn't sure, to be honest, Ellie. I just factored to see what I would find. But once I factored, I can see that there is only a hole. And I am cheating a little bit. I have something else memorized that you should memorize. They can't ask you to fix a function that has a vertical asymptote. I lost Canvas on that. They can't ask you to fix a function that has a vertical asymptote because it's not easily repaired. The vertical asymptote is a function, is a feature that choosing a value of A or something isn't going to help. So I knew that I was either looking to fix a jump and or a hole. Any questions about that? Please.
So is A -2 or?
Not yet. What we decided, Sarah, was that when x is -2, the y coordinate of our function is A. We don't know the value of A yet. All we know is that when the x coordinate is -2, the y coordinate is going to be A. That's all we know.
So would the next step just be plugging in -2 to the equation on the right that we simplified?
We can't really do that because this equation, if you plug in -2, is undefined. But you're close. Somebody help me for him. Yeah, you can't, if you plug -2 into this, the answer is undefined. Jackson?
Plug in a little bit more and a little bit less.
Genius. A little bit more, a little bit less. So plug in a little more than -2. Now, back to this one again. If you're plugging in a little bit more than -2, this is equal to 1. So we don't have to worry about it. These two divide to make 2, so this becomes an easy computation. It's simply 2 multiplied by -2 plus -4, which is very, very close to -12. So you have a list of XY pairs. All of these XY pairs are continuous. There are no holes, there's no jumps, there's no vertical asymptotes. Until we get to -2, at x equal -2, we know the y coordinate is A. A little bit more, we know the y coordinate is -12. We really should back up, as Jackson said, and find out what's happening here. But it will be very similar. So -2 minus 4. That's approximately equal to -12 again. If I kept putting in x and y coordinates here, again, I'm not going to have any problem because I'm plugging them all into the same formula. The only place that was even a concern is this spot right here. It's the only place I'm worried about making sure the function is continuous. Let's check the whole room real quick. Who knows what the value of A needs to be? All who know, raise your hand, who knows? What does A need to be to ensure that when you look at the list, and you're looking at every single possible XY coordinate, you never have a missing Y coordinate, you never have a place where the Y coordinates and the X coordinates aren't perfectly adjacent. So like here we go to -2 minus to -2, those are very infinitesimally close to each other. These two must be infinitesimally close to each other as well. So this is what A has to be. Everyone who's handed up gets paid. Let's go, Soren, what do you think? -5. Thank you for Soren. That's exactly -12. So A is equal to -12. You figured out what the value of A needs to be to guarantee that the function f is always continuous. But this equation here.
Yeah.
So what I did is I said to myself, I need to plug in an x coordinate that's slightly more than -2. So I look back up at f, and I look at the instructions over here, the instructions say, if the x value is exactly -2, the y value is a. But my x coordinate that I'm choosing isn't exactly -2. This one says, as long as the x coordinate isn't -2, here's your formula. So that's the formula I want to use. So I came over here and said, oh, here's a simpler version of that same formula, where this divides to make 1, this divides, oh, that's where it came from, right there, 2 times x minus 4. 2 times the x value minus 4. Anyone else, questions? Please, Alex.
So with x equals -2, how does so simplifying the equation, how does the x plus 2 over x plus 2 not equal 1? Like.
Oh, this one here.
Yeah.
If you plug in exactly -2, Ellie, what is this equal to?
Oh.
0, what's this equal to?
0. But then how is it equal to 1, which is barely above,
Oh.
barely below?
If it's barely above or barely below, this will be some number like 0.00001. This will be exactly the same value.
Okay, so
So whenever you have something divided by its exact self, that's equal to 1. The only exception is 0 over 0. So this is equal to 1 as long as it doesn't become 0 over 0. All other cases, it's equal to 1. Perfect. Other questions?